The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to the Lighting Controls Podcast. We have another fantastic guest for you today who has been on the show more than once from what I recall. And before we get into everything, let me just take a second to remind everyone, today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. Got a lot of information, including stuff about the NAILD LSC. You missed it for the first round, but we are going to do it again. So please check it out. Let us know if you're interested. Would love to have you involved in the NAILD LSC. Also, huge shout out to our sponsor for this episode, which we could not do this show without. MW Connect is our sponsor for this episode. You can check them out, mwconnect.us. That's their URL. You may know them previously as McWong. They rebranded. Now it's MW Connect. They're still the award-winning lighting controls Bluetooth mesh solution for your system, for your projects out there. I mean, they really care about their projects. And every time I talk to them, I'm always just astounded by how much they care about the success of their projects, and they really want to make sure that people are walking away from the experience of MW Connect products with a great impression in mind. And they've been around for over 40 years now, so they've done this and they're not going anywhere. So they're worth your time to check them out if you're unfamiliar with them. mwconnect.us. But anyways, let's get into the conversation. So, as Ron alluded to, we have a returning guest, Steve Mesh, who I believe is officially our most attended guest on this show. Welcome back, Steve. For those who have not seen any of the episodes you've been involved in, do you mind just giving us a quick breakdown on who you are and what you do?
Sure. I've been mostly a lighting designer for a long time. That's why I call myself an industry veteran at this point. I tell people that I cut my hair this way so they can't tell how old I am. Been around for a while. And I've done mostly lighting design, but also have worked in other aspects of the industry. So I actually did about a 10-year stint in the manufacturing side, sales side, which was really interesting, actually, because people weren't paying me for my time. You know, they were trying to buy equipment. So I learned to actually figure out how to explain things fairly succinctly, because, as a lighting designer, you're paid for your time. So I could pontificate all day long, and hopefully people would pay me for that, right? I was the resident lighting expert at PG&E's Pacific Energy Center, which actually no longer exists. That's a whole long story. San Francisco. Anyway, the West Coast has done a lot of pretty amazing things to push energy efficiency. So I've been involved with network lighting controls education for a long time now.
Right.
Long time. So I've got a lot of interesting anecdotes and experiences to discuss relative to that.
No, totally. And that's the reason why we wanted you on for this episode, is because you have this experience that very few people actually get, which is tracking a project from the very outset to the very final moments and being able to see every step along the way, which is, if you don't mind, just let's hop right into this, because I think it's a really fascinating project that really brought, pun intended, a lot to light.
Yeah, it was rather amazing. So do you want me to give you a quick overview of what this was about?
Please.
Yeah.
So I think you guys are going to both love this. Ron, I'm going to be very curious to hear your reactions to some of these things, because I know you deal with these issues a lot, as well as Webster. This was a project called Living Lab. And let me back up a little prior to that so you'll understand what this was about. In the mid-2000s, the New York Times built a new corporate headquarters building in Times Square. I don't know how many people are aware that that's why it's called Times Square. It's because that's where the New York Times is. So they decided to build a giant new tower. I don't know how many stories, probably 50, or more. And what they did is, they had the whole retinue of people on the team, which included a lighting designer. Amazingly, it was actually somebody who used to work for me. It was Susan Brady, very famous New York City-based lighting designer. And they did this really great bang-up job, and they used a network lighting control system that was available at the time. That was a long time ago, but there were systems in place, right?
Right.
In addition to that, the DOE said, "Hey, let's get Lawrence Berkeley National Labs to do M&V, metering and so forth, to figure out how much energy the network lighting control system saved from max connected load, even for a new system." And I don't know if you guys remember the number, but it was 38% savings. So basically they said, hey, if we use all of these control strategies, photo sensors, occupancy sensors, et cetera, scheduling, et cetera, et cetera, et cetera, we think we're going to save a fair amount of energy. And, 38% is a pretty incredible number.
Well,
so
absolutely, and especially at the time when the technology was still, in some regards, in its infancy, because you had networked lighting control systems, but they were not. They were shadows of what networked lighting control systems are now, and so the capabilities were quite limited. So I would argue that savings, if we took a modern system and applied it to that infrastructure, they probably would have seen even more considerable savings.
Since you said that, I'm going to elaborate on that for a second, because that's really important, because that's money.
Right.
It converts directly into money, right? Yep. And that's what justifies purchasing, installing these systems. So actually, let me elaborate on that just for a brief period of time. The DLC has determined through studies that the average savings, they did a study of 114, I think it was 114, or maybe it was 194 buildings. I don't remember which of the studies. In that, what they determined is that the average savings across that whole group of buildings all over North America was 49%. Whatever kind of buildings they were, and I don't know if this was new construction, retrofit, whatever, probably a lot of new construction. 49% reduction from max connected load is unbelievable, right? I actually have a blog post that I posted myself on LinkedIn because it didn't fit yet on the Lighting Controls Association website. Oh, sure. But it's about payback, and I'll tell you what that's about. I did a project in California that was installed 12 years ago in 2013, and the cost was $40,000. Guess what? The annual savings was $43,000. And the funny thing, part of the reason for that is because the savings is 80%.
Right.
Well, guess what? I actually commissioned the system. I've used a lot of systems in classes, so I've had a lot of opportunity to fool around with stuff. So, I'm like, I know how this works. I told them I'll do the commissioning, and I did, and I tweaked so many different things. They saved 80%. I still have remote access to that system, and I could go and look at that literally right now. It's going to say 80%. That's incredible. Just because of things like tuning, so many spaces are overlit, right?
Well, and just to be clear here, the 80% is basically going from fluorescent malachite or whatever the original source of illumination was, and converting that to LED, and then layering on top of that a lighting control system. And so the combination of the two yields that 80% savings. Is that accurate?
In this case, it was not actually based on an LED conversion. So
this is brand new construction.
So we actually saved 80% for max connected load, not because of LED conversion. That's pretty amazing.
That's phenomenal, right? Yeah, for sure.
So it turns out that, in my little blog post that I had to self-publish at this point, if you do the math, it turns out that the return on let me stop for a second. When we talk about this stuff, people are always talking about what's the payback? Like, how short can the
Right.
payback be?
Right.
Well, then what happens is we're thinking about it in very short-term periods of time. But if you think about how long the system might be in place, we should really be thinking, like, what's the life cycle return on investment, right? Forget about
Yep.
cost.
Yep.
What's the life cycle return? I did those calculations, and I couldn't even believe it. I did them 3 more times just to check it. The return so far on that has been $500,000.
Wow.
Wow.
$500,000 on an initial outlay of $40,000. So again, that was based on 80% savings, which is granted unusual, right?
Yeah.
So
Yeah.
I redid the equations based on the 49% that DLC uses. Guess what? Still $300,000 return on investment. You have to wait 12 years to get that, but it's been in place for 12 years. They
Well,
haven't
then
even
that's
touched
right.
it. Like they're, it's just cranking along and saving
Right.
Yeah.
a lot of
I mean,
interest.
Well,
it's a
and
good point because most of these systems are going to be in place for 20,
Long
25
time.
years, probably on average.
Right. Right. We should be figuring out, well, if I were a building owner, I would be thinking, yeah, okay, we all know that it's a hard sell to say, hey, you should put in
Yeah.
something that's going to cost $40,000 instead of single pole, single throw toggle switches. But if you think about what you're going to earn on that, it's like, oh my God, like everybody in the world should do this on every single project, But so anyway, that's why I did the calcs. I mean, I usually so caught up in the technical stuff, I rarely touch that kind of thing. And then if I ever talk about it, I don't want people to hold me to those numbers. I don't want to say, hey, I've done projects where you get 80% savings. Well, it's because I tweaked it, and
Well, and
anyway.
I think that's something that I know a number of people push back on when it comes to energy savings through lighting controls. Is like, well, how extreme are we going to have to dim stuff down, and how aggressive are we going to have to be with the timeouts? And it's like, okay, sure, but at the same time, how many nuisance calls do you get on that project? How many times does somebody call to complain that the lights shut off on them when they shouldn't have? 0.
So,
exactly.
Remember that I'm the one who commissioned it, and I'm pretty knowledgeable about these systems and the variables and so forth. So, that whole thing was separate from what we were really going to talk about today. Was an interesting experience because I worked very very closely with this was a University of California building, and their own in-house electricians actually installed it. So I had an extremely close working relationship with those guys, the facilities people, the electricians. I was there for a lot of it. There were even some issues. In fact, since we're going to talk about this living lab project where I observed and saw a lot of interesting issues, I'll tell you about something that happened on this University of California project that you guys will just love. One of the things that happened was that I programmed the system to not turn lights off during the daytime hours between 7 a.m. and 1 a.m. But, reduce down to 10% upon vacancy. And even at that, we still save 80%. I could go on it right now and it'll say 80% savings.
Right.
Then overnight hours between 1 a.m. and 7 a.m., we shut it off because we all figured, okay, no one's going to be in these labs. It was a lab building. Figured nobody would be there. Pretty quickly, I saw that right at 1 a.m., lights would go off and come right back on. Time delay of 15 minutes, go off, come right back on. Another 15 minutes, go off, come right back on. And none of us could figure out what the heck was going on. And it turns out that this was a situation where they had 3 very small aux sensors integrated into a 20-foot linear pendant fixture, all attached at one end to a controller that had sensor input. And what happened was the drivers were 277 primary. The sensors were connected by wire back to those sensor input ports on the controller at one end of the strip. Do you want to take a guess what happened? The electricians decided to strip off the shielding,
Oh.
which they weren't supposed to do, and the 277-volt primary induced an inrush every time the sensors changed state, and it immediately reactivated the control wire.
Oh my
And
God.
I was there for a lot of the, what was going on, so I knew a lot of what was happening there, but I didn't actually ever see them do that. If I had seen them
Mhm.
do that, I might have been like, "Hey, why are you doing that?" These guys said specifically, "Don't take the shielding off."
Right.
Even if I had been there, I'm not even sure if I would have really
Well,
known to do that, because I'm like, I'm not the one installing it. I don't care whether the shielding's
Right.
on or off. But that was the
it,
reason. And
yeah,
it's like, I
it's
don't know
one
why
of
you
those
guys decided
things.
to take it off, but that's what caused the problem.
It's one of those things that is really interesting to hear about after the fact, because you know that unless there was a skilled person actually who was knowledgeable of the system and could trace where the problem was, it
hmm
would be one of those situations where, this manufacturer's junk. That
Yeah,
would be the end of the
absolutely.
story.
Oh, sure, that's
Yep.
what they would have thought, right? Because they're
Right.
not experts in it, right?
Right.
Right, and that leads directly to what we're going to talk about with this living lab project,
Yes.
because it was a similar type of situation. So this was, in fact, really a retrofit situation, and so is the living lab. So to continue that story, after the New York Times project from the mid-2000s, then 10 years later, DOE, who, sponsors all of this work, said, "Hey, the New York Times, that was great. They saved 38% from max connected load." Well, that was new construction, and they had a lighting designer, and they had all the latest and greatest equipment,
Mhm.
right? What if we were to do this on a retrofit basis? Then what would it be like? That was a
Yeah.
very interesting and different experience. But they still wanted it. So not only did they want to see what the potential savings was, right? Because that's what gives you the
Mhm.
money to justify doing it. But they also wanted to understand what kinds of issues would come up when you're
Sure.
actually doing this on a retrofit basis. That's what we found
Right.
out. So I'll give you, I'll go over some of this stuff, and please, just break in whenever you have questions or comments on any of it. Um, so basically, I'm not going to give anybody specific info on where this was, what building, what company, any of that stuff at all. But I will just tell you that it was a 43-story corporate headquarters building of a major financial services company in a
Mhm.
major city in the United States. One facade looked west across a river, and obviously had pretty unobstructed views, to the
Mm.
afternoon sun, in a curved facade.
Mhm.
And the building, was complete. They had uh, fluorescent fixtures in there, T5 and so forth. And what they did is they said, "We'll let you take one floor and change the lighting and lighting control systems on that
Mm.
floor." And what happened was they put in a different system and different fixtures on each of 4 quadrants. So it gave them an opportunity to contrast and compare, and it was really,
Interesting.
really interesting. Yeah, yeah. So I'll get started by I'll let me just jump right into
Yeah.
with the first one. I ended up being on site for 18 nights of the initial part of the installation, and then
Mhm.
I had a bolt. I couldn't stay for the whole thing. So the
Well,
first one had.
so you were there
Go
just
ahead.
to observe for 18 nights, though. You weren't like actively
Right.
participating in anything,
So that's a
or
little
were
complicated.
you?
So officially, my job was as a consultant to Lawrence Berkeley Labs. In fact, some people who listen to this probably know this name. Francis Rubenstein, who's a very major dude in the field, had worked at Lawrence Berkeley Labs for a long time and dealt with a lot of stuff related to network lighting controls and Dolly and so forth. And he had just decided to leave after decades, so they needed somebody to kind of take over. And I worked on this project as a consultant, but my job was not to specify or to serve as the official, lighting designer in charge or lighting controls person in charge. Because the whole point was to say, hey, if you don't have somebody like Steve Mesh or somebody else like you guys, then what happens? So no, I absolutely was not the official person. But as we go through this, you'll understand why it was beneficial that I had a lot of knowledge about it. You'll see that as we go along. So I'll jump right in with the first one. The first quadrant was one of the two quadrants that was in that curved facade that faced west across the river. And they took out the existing T5 fluorescent and they put in new T5 pendant LED fixtures with up and down light. Well, guess what? They also wanted the uplight to be separately controlled from the downlight. And just as a quick aside, when I've discussed this with people and explained it during classes and webinars and conferences, a lot of people are like, why would you want to do that? And that costs so much money. And so from a design viewpoint, what I explain is that once you separate the control, you can then light the ceiling evenly, irrespective of what's happening from the down component.
Yes.
So, right.
Well, and
So
you also
might say,
have two layers of light at that point. You have an indirect,
different layers.
even layer, and you've got a direct layer that you have complete control over.
But even at that, remember that the entire uplight layer, even if every single fixture is on for the uplight component, it doesn't have to be on at 100%.
Right.
Right. It can still be dimmed down. So, we all know, the three of us know, hey, I'm sure I can speak for all of us when I say that we ultimately want as much control as we can have.
Yes.
Who wouldn't want as much control as they can have, right? To provide as many layers, as much distinction to get the right mix and so forth.
Yes.
Okay, is there a cost component? Yeah, sure, absolutely. So anyway, that was but this is Class A office building. This, if I told you the name of the company, you'd be like, yeah, they have the money to do that. It's not a problem.
Yeah, of course.
So trust me on that one. So what that meant is that they had two controllers. Where do you guys think those controllers? Controllers and drivers.
Sorry. Yes, two power packs. You're right as well. Yeah, whatever controllers were being used.
Do you guys want to take a guess as to where those were located?
The worst possible location.
That's right. Where do you think that was?
Front of house ceiling, right in front of everybody's view.
Yep.
In the plenum.
Oh.
And, so they had these pendant fixtures. So they actually did have a local lighting designer, a very prominent lighting designer, work with them because this company worked with this lighting designer routinely, and they helped to select those. And, they were great fixtures, but the fixture company said, we can't integrally mount the drivers and the controllers because there's not enough room.
Yep.
Once I got to the job site, the very first thing that I did was I opened up one of those fixtures. And if I were to show you the photo from my 63-page PowerPoint, you would see that there was enough room in there for about 20 controllers, literally 20 controllers. So I'm like, so why did you guys say that? I said that to myself, right? I didn't engage in that conversation with the manufacturer. So of course I don't really know, but I have to assume that the reason that they had that stance was because they didn't want the liability of putting all that stuff in, not only the two different drivers but also the controllers.
Yep.
They were probably
I would imagine that
it may have affected their UL listing.
That's what I was.
Right, depending.
That's exactly where I was going.
Could be. Right, could be.
Because they're all UL listed devices on their own.
Correct.
But that's not a UL listed. What's it? Enclosure or something like that.
Right. And so one of the things that brings up is the issue of when you're making selections, when you're deciding what to specify or what to purchase and install, do you want to go with fixture manufacturer and controls manufacturers that are separate? Or do you want to go with something, let's say, where two companies are part of the conglomerate, where on the fixture spec sheets, they're even going to refer to the controls that the sister company makes because they're trying to make more money.
Yeah.
But once they do that, it means they're taking responsibility for the whole thing, and that's why they include those as standard options, right? So those are interesting things to think about. I'm never going to tell anybody that they should do this or that. That's not my job, my place to do. It's not appropriate, but it's something to think about, right? If you want to avoid a problem, that's something to really think about, right?
Absolutely. No, and this is always part of that debate. People always come to me and say, well, you always spec non-proprietary, right? And it's like, well, first of all, in North America, you can't. But second of all, sometimes you want the brand to own the entire scope. You want them to have through and through responsibility. And to your point, like instead of OEMing or field modifying these fixtures, you can just have them shipped from the factory ready to go. And that's what we're seeing with LLLC and its resurgence right now.
Right.
So I think there's, like I always say, there's no silver bullet. Everything's got its proper application.
Sure, absolutely. Right. Again, just so it's absolutely clear to anybody listening, I have to remain agnostic. I don't work for somebody, and I'm not pushing their specific equipment. I'm not going to ever tell anybody that unless I decided to work for some particular manufacturer.
Right.
But no, it's not my place to do that. I'm just bringing up what I saw. That's the whole reason I was there, and I'm like, oh my God, there was space for 20 controllers in that housing. There was no issue whatsoever. So that just created a problem, and that was just because they didn't want the liability. That's all, right? I understand that, but so it meant that these electricians had to, remote that stuff. So of course they had 2 stems for a 5-foot fixture. Well, guess what? They had an SJ cord running down one stem with 5 conductors. They had SJ cord running down the other stem with 4 conductors. What were those conductors for? I'll count them off here in my hand. Let's see. So we had 2 power wires. Let's say this was for the downlight component. 2 power wires, 2 0 to 10 wires, and a ground. The other side, for the uplight component, we didn't need the ground, but we needed the 2 power wires and the 2 control wires, right?
Yep.
Okay, issue number 2. This was quite something. So the first SJ cord, and I'm looking at the photo right now on my screen. You guys can't see it, but it's sure enough. It has a green, a white, a black. And instead of gray and violet, which now should be pink and violet because they changed the rules for color for 0 to 10. But anyway, instead of that, what they have is green, white, black, violet, and violet with a stripe. So like, have you guys have done that for Dolly, right? So that you're differentiating the Dolly.
Well, I mean,
the Dolly
you also see sometimes that they use these different color combinations when you have like multicolor controls that need to have independent commons or independent positive terminals. So you see the gamut in wiring,
right?
Yeah, I don't know.
So
and
was,
also if you've ever stripped a category cable, you've seen the striped wires. So
right. So okay, it wasn't black, white, green, gray, violet, but it was black, white, green, violet, and violet with a stripe. But at any rate, it allowed them to differentiate between the 0 and the 10-volt side of the 0 to 10, right? Okay, that was pretty okay. The 4-conductor SJ cord, I might actually have problems sleeping tonight because I'm looking at the photo again. This was just incredible. There was a black, a white, a green, and a red. And that you guys have probably seen stuff like that, right? When you have two circuits, right? Like 2-circuit track or something, whatever, right? Well, right off the bat, even
or a feed through from a dimmer.
So who provided the SO?
I don't know.
Okay.
I don't know because again, I wasn't serving as an actual specifier, so I
Yeah,
didn't have
sure.
all of that gory info.
Well,
I arrived at the job site with whatever I knew, which was not very much
Right.
because it really was
Yep.
done on a retrofit basis,
and
right? I'm like,
just to
not
check,
too much info here.
this luminaire that has this up-down component, technically, is this a custom build at this point? Because it sounds like the manufacturer was like, well, we can't fit equipment in here. So they did direct indirect with independent control on a regular basis.
I'm not sure if this specific manufacturer made this specific type of fixture with
That's what
separate
I'm wondering,
direct
is if
versus
this
indirect.
particular fixture may have
Yeah.
not been designed for this specific. So, custom
Right.
is not like you're fabricating the entire housing separately. It just means that you're deviating from the spec sheet. But that being the case, I
Well,
would imagine. Go ahead.
Well, remember that the likelihood at this point in time, this was the mid 2010s, typically they might have offered this, even if they had separate control, it might have just been switched and not dimmed.
Right.
True.
But even if
True.
it was dimmed, it might have just been dimmed, there. But it means they would have had to bring 0 to 10 lines in, right? It still means they would have had to bring 9 conductors in.
Yeah, so the drivers
really
were
sure.
still integral to the fixtures. It was the controllers that were remote to it. But
Right,
yeah, I mean,
right.
so
the 0 to 10 lines, that's what my train
Yeah.
of thought was about. If they were integral, if the drivers were integral, then all the electricians would have had to do is connect
Power.
hot, neutral, and
Right.
ground.
right.
Yeah.
Right. Because all the other stuff would have been integral.
Right. And so the thing here is the point that I'm trying to get at here is basically with the SJ cord, where you have this custom function or this custom installation, at least deviating slightly from the specs, probably was provided by the electrician. It was probably not provided by the manufacturer.
That's a great question, and unfortunately, I don't recall.
No, for sure,
I
but
think it was actually probably provided by the fixture manufacturer.
really, okay,
I think so.
interesting.
Because I think they took responsibility for everything that went up to the ceiling.
Oh, I see. Yeah, so it's a decorative.
Right,
It has
and
a
then
decorative
in
element.
the ceiling, they had boxes in the plenum
Yep.
to house
Yep.
the drivers and the controllers. Right,
Interesting.
right, because it was decorative element. Right. It's
Yep.
just a white SJ
Okay, fair
cord
enough.
going up
So-
each stem, right?
So the manufacturer provided the SJ cord,
Mhm.
and they probably just sourced whatever was least expensive to provide
Or
this.
it's probably stuff they just had lying around.
Or that, yeah.
Or that.
Right.
Yep.
And I don't have an issue. What I tell people when I teach about this stuff in classes is that the electrons don't have any idea what color the insulation is.
Right. It's true.
Right? It's not how it works.
Yep.
They're not
Yep.
sentient beings, right? So it doesn't, I don't particularly care myself. I would just make sure to check and figure out, but if the correct installation depends on those specific colors, then you may want to be careful about it, right?
Yeah.
So
Yeah.
in that second SJ cord with the 4 conductors, here's what they had. They had a black, white, green, and red, right? Which we know could be for multi-circuit stuff or whatever stuff you guys just mentioned.
But if you mentioned at the beginning, there's no ground on the 4 conductor
Yep.
side.
Right.
So the green
they
is
didn't
not
need it.
ground.
No,
It's not ground. It turns out that the green, I'm looking at it in the photo right now, it says C2, which must mean circuit 2, I guess. I don't know. I guess that it probably meant the second circuit, out of
Okay.
Yep.
2. Maybe it meant the uplight component. It says 0 to 10V green. Well, we know it's green because it's the label's stuck on the green wire, right? But it says 0 to 10V. The other one, which is written by hand, by the way, which drives me out of my mind. The others are all typewritten. I don't know why that is. It says C2, number 1, 0 to 10V. I don't actually even know what number 1 means, but those two say 0 to 10, right?
Mm-hmm.
The red wire is labeled and it says hot. The white wire is labeled and it says neutral. So I have to assume that the red wire and the white wire are the line voltage power wires. At least that's what they meant, right? But the other ones are labeled 0 to 10, so I can reasonably assume those are meant to be low voltage. They're all the same.
my
They're all
God.
the same gauge, right?
This is
Well,
so
with 0
easily
to 10,
going.
that's south.
Yeah.
Yep.
This could so easily go south. I mean, the reason, first of all, the reason we changed from gray and violet to pink and violet is because of the fact that people were wiring 0 to 10 volt wires onto the line voltage, thinking the gray was
277 volt
the
neutral.
The gray was
neutral.
277. Yeah.
Of course. Right.
And so as a
But so
result, they said, okay, no more gray wire. Has to be pink.
Yep.
Yep. So remember that the way these guys labeled this, that because they did it by hand, right? I guess they thought they were being nice. But if you say 0 to 10 on one conductor and 0 to 10 on the other, we don't know which is 0 and which is 10.
True. Yep.
Right. So guess
I
what
guess
ended up happening
you could
is-
meter it if you wanted to, because you could measure the 10 volts coming out of the driver.
Yeah, but now we're also, and
electricians
I
weren't doing that. No.
I don't know where this is going, but now we're also assuming that these 4 conductors, of which the colors don't make any sense for this, we're now assuming they're wired properly inside of the fixture as well. So
Of course, we were assuming that. Well, I think that's a reasonable assumption only because I'm pretty sure the manufacturer did that. So they knew. So, it made, they weren't going to call the wires that they labeled as the line voltage power wires, and then bring them in and attach them to the dimming part of the driver, right? Well, sorry, not the, to the, so convoluted.
Well,
I
think that this is the crux of the issue, or at least I suspect, because of the fact that this is a complex set of parts. It is not an easy solution to do it this way. If you put the controllers inside of the box, inside of the fixture, you in most cases, I would imagine you would only need one set of line voltage wires going into the fixture. You wouldn't even need 2 sets because it would split out and it would function as a branch circuit inside the fixture. So
right.
That being the case, this is further evidence towards the argument of LLLC and having your controllers inside the fixture.
Almost everything that I observed there, I'll call them issues to be nice, almost every one could have been avoided if they had used LLLC. And in fact, one of the 4 quadrants actually was installed with LLLC with a company was very well known, that's actually getting out of the business for some reason now. Guess what? That was the one quadrant where there were no issues. Because everything was pre-installed and there were no wiring issues. Because the electricians all know how to install power wires, right?
Right.
I've installed black, white, and green wires on things since I was literally a kid. That's just not rocket science, right? So I know we have limited time, but I thought if, there's a few other things that I think you'd be particularly interested to hear about. One of them was that in the next quadrant, which actually had linear 28-foot rows. So they took the existing stuff out, put linear 28-foot rows in. That had some interesting issues as a result. It didn't have enough room in the fixture. It was a very minimal fixture, so it couldn't have separately controlled uplight versus downlight. So it was all just one. That made it a little simpler. But in a 28-foot run, realize that you're going to have some 8-foot sections and at least one 4-foot segment to make up 28 feet. Right. There were a couple of issues because of this. I'll back up to the first quadrant for a minute. One of the issues is that this NLC vendor had just come out that year with their wireless version of the system. But this was really early days, and people didn't typically have UL 924 rated EM versions of controllers and things like that.
Mm-hmm.
So they had a method of saying for EM, you have to bring in a tether, meaning a wire connection from a wireless controller over here to one wired controller over here, such that when the wireless signal dropped out, that signal over that tether would drop out, and therefore the wired controller in the EM fixture would know there was an emergency, and that was wired to a generator, and that had to come on, right?
Mhm.
That's the way they dealt with it at the time. The drawings, which were provided by a local rep, who's actually a great guy who I know, were extremely non-specific. So just as an example, they actually show line voltage supplied to the fixture on one side and line voltage supplied to the fixture on the other side, with no mention of which had to be supplied through EM circuits attached to a generator and which were
So you
normal.
could just end up with two
Yep.
normal circuits running to the fixture.
Yeah. Or the wrong one on the EM, which wasn't going to come on because it had already
Right.
dropped out. So it's like,
Yep.
no, that's
Yep.
not how. So it just shows you can't do stuff like that. You just can't. This is life safety, and they even
Well,
had
there's-
an engineer check all this stuff, right? I'm like,
There's coordination that
Where's the
needs to be
checkouts?
done, right? And so
Mhm.
I mean that's further evidence of having somebody involved during the even the shop drawing process.
Yep.
Because I would imagine
Yep.
that in the shop
Mhm.
drawing process, if somebody were skilled enough, like Ron, who was looking over the shop drawings and go, wait a second, where's this
Oh, yeah.
information? Like
Right.
that way you've got assurance. But
Right.
this living lab, you didn't have that. You basically just kind
Yeah.
of
Yeah.
set the boat adrift and saw what happened.
Mhm. Yes, there were things that fell through the cracks, and it was pretty amazing how many things fell through the cracks. So like I said before, the big takeaway for me was that if they had installed LLLC equipment all over the place, they would have eliminated almost all of these issues because all the electricians would have had to do was just bring power wires to the fixtures.
Right.
All the rest was commissioning, right? But there were some other issues like this emergency stuff, which is a little more complicated, right? But it's life safety, and you just can't fool around with it, right?
Right.
So if you want to, so my overall takeaway is, hey, if you want this to be the simplest installation as possible and to guarantee the success of the deployment, probably go with the easiest thing to deploy, which is LLLC. Right? That just, again, I'm not pontificating for that. It's not my place to say you have to use LLLC, but it would have avoided almost all these issues.
Well, and I think that's again, like the fact that the project didn't allow for you to be hands-on in the middle of the process. That's where LLLC, Triple LC sings the loudest. It is like you just want to basically be like, I need to trust that every domino is going to fall correctly, then do it that way.
Yeah. Oh, and
it helps,
to add to that,
it goes a long way. Yeah.
when you think about the extra work the electricians had to put in on everything, but wiring drivers above controllers above the ceiling, and connecting those 0 to 10 lines, and then inevitably, I'm sure there were reversed lines and missed connections, and the
Yes, there
extra
were.
time
They smoked
and
some
labor
drivers. Yeah.
and wiring. There, there's a lot to, but people don't always factor that in. They look at the cost of the control system and go, "Oh, I don't want to pay for that. That's too expensive." But you'll pay the extra whatever dollars to the electrician to do the extra work for the other system that saves you, in theory, saves you a couple of bucks. It's crazy.
So the funny thing about that is that there was a study that I believe DLC commissioned at one point that I think was done with NIA, if I'm not mistaken, where they asked people, I think they kind of polled people in the Northwest maybe, I think like electrical distributors and contractors and so forth, about the idea of using LLLC stuff. And this was quite a long time ago now, maybe up to 10 years ago now. And basically the overall feeling among those people that they asked was, that's crazy. Like, we're going to pay for every single fixture to have its own sensor? Well, you guys know that the cost of these sensors has come down so far
Oh
that
yeah.
it's
Oh yeah.
not, it's probably very competitive. And then
Yep.
they're not generally taking into account the cost savings based on the installation and the commissioning
Right.
time. Once you do that, so this kind of happened right around the same time. And what I thought was, when I read that study, is I thought, you guys have it exactly backwards. My actual on-site experience with this is that the only quadrant here out of the 4 where there were literally no issues, literally 0 issues, was the one that had LLLC, because there were no install. Remember, this was really done on a true retrofit basis, even with
Right.
some pretty high-powered consultants that ultimately involved. It's still amazing the stuff that slipped through the cracks. One of the just very briefly, because I know we're running out of time, because of this issue of the 8 and the 4-foot segments to make up the 28-foot run. One of the things that happened is that they didn't coordinate that appropriately, and they designated the wrong segments as EM. Because remember, they weren't going to designate the whole 28-foot run as EM, right?
Right.
Too much load on the generator.
Yep.
It turns out that the difference between the input wattage to the drivers for one quadrant of one floor was no big deal whatsoever. But I did the calculation, and this was a 44-story building. It turns out that because of that little mistake of which of the segments, 8-foot versus 4-foot, in that 28-foot run were actually on the EM circuit, the difference in the load on the generator in the building would have been 32,000 watts, 32
wow.
kW. That's the difference overall.
Wow.
So you could see, you can't fool around with this stuff, guys, Another
Yeah.
very quick thing that happened on that was pretty amazing is that was actually a dolly system. It was a true dolly system. One of the things that happened is that, just like, there are a bunch of manufacturers that will say, okay, we've got this is real dolly, you got to bring wires to the actual dolly drivers and the fixtures, but for some reason they don't actually have dolly switches and sensors and so forth. So that means they use other stuff, and then they, have other kinds of cable for that. It could be just 18.2 or whatever. In this case, they had a special cable. The manufacturer gave it their own brand name, but it was actually a Belden 1502 cable. So it was 2 twisted pairs plus an extra for a drain. Turns out that wasn't on site when they started to install this. There was a note on a drawing that said the contractor has to pre-order that because they're the only ones who are going to know how much they need, right? Well,
Yep.
they never
Yep.
did that. It was a tiny little note on one of the drawings. This was retrofit. They're like, it slipped through the cracks. Guess what happened? It turns out they actually opened the tiles on 3 separate occasions. Once to bring power wires to the fixtures, second time to bring the dolly wires to the fixtures, and a third time to bring this special cable to the peripherals that were not integral to the fixtures. And by the way, in that zone, guess what happened? You guys would assume that they would have installed 2x4, grid ceiling in a rectilinear fashion wherever we would hit the curve of that fan-shaped segment that it hit. It's not what they did, because this was super duper Class A and incredibly, big deal financial services company. They installed that in a fan-shaped, the grid in a fan-shaped pattern.
Yep.
Which means that they literally cut every single tile in a keystone shape. It's probably only like 1 degree cut, but every single tile was cut. So you guys know, if you pop up a tile and you keep doing that over and over, you're going to mess up the tiles, right?
Oh yeah.
You're kidding. Well, there's no reason that should have happened, but it would have required somebody to say, oh, we see this note on the drawing and we better order that stuff, or they're not going to be ready to install in that quadrant. So that's just some of the things. There are some others, but that gives you a flavor for this, right?
No, and it's so interesting, and you're right. We are running low on time, and maybe we'll have time for another anecdote after I kind of recap this. But I mean,
Sure.
I love these stories, and the reason why I love these stories is not because it's like shame on you or we should have done better or anything like that. What it does is it gives you a vertical slice of the industry in a very specific moment in time. Because right now, yeah, there are a lot of options triple LC wise. Back then, there were not a lot of options for triple LC.
No.
And in fact,
Yeah.
the ones that were available for triple LC at the time, some of them don't exist anymore. And so people who have installed triple LC projects from early 2000s now can't do anything with their system because the brand doesn't exist anymore. But the thing to really note here is the fact that you had 4 different systems, 4 different installation capabilities, 4 different scenarios that were the same scenario, but with exception to the controls platform. And the fact that the only system that didn't have issues with the installation was the triple LC says something very specific. And it's not use triple LC on every single project. It's that the installers have the tendency to pick the wrong decision when given an option. And could be victim of 50-50. It could be any number of factors. But by doing triple LC, you are eliminating choices. And you're dialing into what okay, put the system in, put the fixtures in. I will take care of the programming, and somebody else will worry about how all the pieces fit together. You just need to get the pieces in place and powered. And that's the mentality with triple LC and why it's such a great resource. At the same time, not every fixture can have triple LC. And so in a grid format project, sure, you can, if you have 2x2s, you can do 2x2 troffer fixtures that have the triple LC module right in the side of it. Some recessed downlights even have it, especially if they have a trim ring. But when you start getting into custom linears and you start getting into really high-end products, you're no longer talking triple LC. You're talking custom or something else. And so triple LC goes up to a line and doesn't cross that line. But again, in these situations where you want to write things down and will never see the project again unless there's nuisances and you get those callbacks, it's a great solution. And people should be keeping it at the ready, but they should not be relying on it for every single thing out there. And a lot of people think it's either or. Triple LC is actually NLC plus. Triple LC can be a part of a huge NLC system. But you need NLC capabilities to have triple LC. And furthermore, you can have triple LC standalone, but then you can't integrate it. So you need to think through all of the complexities of this. You can't just go triple LC for everything. So,
well, I mean, something that I tell people in classes is you might have a triple LC installation, but the corridors may have round downlights, which likely aren't going to be triple LC fixtures. So somewhere on a project, you may very likely have something which is zone-based, which is going to be different, right? So, the other very quickly really big takeaway from this was that, the very first night, these guys were installing the fixtures, the 5-foot fixtures with the SJ cords coming down on each side for the separate uplight versus downlight and the remote, controllers and drivers in the plenum. But they pulled out these controllers and these were very, very good guys who were very knowledgeable, very experienced contractors. And they pulled them out. I have a photo of this guy who had the wired and the wireless controller in his hands. And it was almost as though if he had a hand free, he would have been scratching his head because he had absolutely no idea what to do with them. And I just kind of couldn't believe that. I thought, wow, this is a major manufacturer. If I told you which one, you'd be like, whoa, that's a major manufacturer who did not really do anything to educate these guys. And, you know, you could say like, okay, well, it was retrofit, so they didn't have like a lighting designer on board at that point, whatever. Doesn't matter. Like if you're shipping product, like ship um, basic spec sheets, or in this case,
Yeah.
because this EM thing where one had to be tethered to the other, that kind of needs like a project specific drawing. Like that's not fooling around, guys. That's a life safety issue.
Right.
Or hey,
Yep.
what about having YouTube videos or having a QR code on a spec sheet that says if you want to see a YouTube video about how to wire it, just go there. That we have that technology now. There's no reason. So with the very minimum amount of education, and by the way, that's what I ended up doing. I said to these
Mhm.
guys after 10 minutes, I said, guys, do you want me to put you out of your misery? And they said, yeah. And I said, just so you know, I'm not doing this to make you look stupid. That's not why I'm here. The reason I'm here is to see how easily people with no hand holding on a retrofit situation can do this. And it was very eye opening because I had already used that system in class. I knew exactly how it was wired. I'm like, well, you know, this is how
Yep.
you wire this. This is how you wire this. Boom. It's very simple. It's not, none of this rocket surgery. It doesn't take that
Mhm.
much, right, to understand it. It's just that it's not 3 power wires. So, okay,
Right.
you know, geez, I mean, I went to art school. If I can figure it out, trust me, an electrician can figure it out, right? But they're not going to, it doesn't come from the ether. Somebody has to tell them. They're not going to guess, right? They can't
Right.
guess. So
Yeah.
that message to me, besides the LLLC issue, is just a little bit of education goes a long
Yeah.
way. And I'm preaching to the choir, but I will also say that that's why it's so important what you guys are doing with the LS classes, the LSC
Oh, thank you.
classes,
Yeah, yeah. No,
because
and
it doesn't take a lot, but it takes
right,
something.
Right.
right. Well, and that's the thing. Like distribution is, there are situations where contractors are buying straight from distributors without
Yep.
anybody else kind of
All
overseeing
the
it, and
time,
there's
all the
Yep.
nothing
time.
wrong with that. But like you said, just a little bit of education goes so
Just a
much
little,
further. And so that's
just a
what we're
little bit.
trying to do with the LSC is getting
Yeah,
distributors to just get
chipping
that
away.
tiny bit of information so that they can move
Yeah,
forward and actually have successful projects.
yeah.
Yeah.
Anything
And
I
like the
can do
one
to
thing that
help, and
we,
the stuff you guys are doing is helping.
yeah, and the thing that we see on site the most, unfortunately, and this project really kind of highlights that, is the simpler you can make things for the contractors, it tends to go
Yeah,
easier. And you see it on a lot of these,
sure.
you see a lot of these large high-rise buildings, right? They have one or two lighting controls guys or controls guys in general, and they are the ones that kind of go floor by floor and do the thing. And that's great until one of those guys is out sick or he's on vacation for a week or 2 weeks, and they
Or
say, hey,
retires.
intern, go finish what this guy was working on because we're behind
Yep,
and we need to finish this
yep.
floor. And inevitably, that's always the floor that has an issue, right? Because it wasn't the same guy, and he
Hmm.
had his wiring method down and how he did it, and then this
Mhm.
someone else picked it up, and it, right. That's always where we see it. Unfortunately, it 9 times out of 10, it's some sort of an installation issue, right?
Mhm.
It's not a manufacturer issue or a hardware. It's
Yeah.
usually an installation issue, and
No, because they
triple
work in the
LC
factories.
helps.
No, of course.
Exactly.
Yeah,
It helps,
yeah, right.
rectify some of those problems. So it's,
Yeah, they're
but
installation
people don't
issues.
think
Yeah,
about that.
yeah.
Yeah, everyone
Mhm.
really gets focused on the hardware cost. Well, this now makes my
Mhm.
fixture cost X more. Well, yes, but
Right.
you're going to spend that much or more on the electrician and the issues potentially, and this alleviates all of that. And unfortunately,
All of it.
it's we're getting there slowly, but
Yeah.
education, right? And projects like this really kind of help people understand that and sort of see it and go, okay, this makes some sense as to why I would spend a little bit more of a premium for product X versus product Y.
Right. Or also that it's also why it makes sense for people to take the classes that you guys are going to be offering next month,
Yep.
even if it only increases their level of knowledge by an increment. It still means that they're going to be at a higher level. And even if it's just a step, I'm like, hey,
Mhm.
whatever it is, like it took me literally 3 minutes to explain to these guys how to wire the
Yeah.
wired controller and the wireless controller and tether it. And they immediately,
Yep.
it's just not that complicated, right? But it took a little. It takes a
Yep.
little bit more than nothing.
Yep.
Take something
Awesome.
more than just nothing. Yeah.
Yep. Well, Steve, thank you very much for your
Definitely.
time today. I'm sure everyone will get a lot out of this. It's great to be able to hear about things like this and get people to understand when, we talk about individual projects, but when you take a study like this where you had 4 different quadrants with 4 separate systems and get an understanding of how that really worked with the contractor and knowing that it was
Yeah.
the same contractor and the same floor in the same building, but 4 systems. And
Yeah.
it's great. And I know we didn't talk
was
through all
amazing.
of it. We barely
Yeah,
got
we
through half of
definitely
it,
need to do a
but
follow-up.
it's it's great to be able to talk about through things like this and get people to really kind of help to see those differences. So thank you so much for your time today. Really appreciate it. I will just close this out and remind everyone that today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors. Wow. Or nailed. Check out our website, lightingcontrolspodcast.com. Got a lot of information, including stuff about the nailed LSC. If you're a distributor or know a distributor or just want to learn more about lighting controls, check it out. Really want to make sure that this is a helpful resource for the industry. But also, huge shout out to our sponsor for this episode, which we could not do this without, MW Connect. Check them out, mwconnect.us. If you want LLC or you want NLC or you want just help on your next project with lighting controls, they are a great resource for that. They will be that guiding hand if you need it for your lighting controls projects. I talk to them all the time about projects where they are just like puzzling through the challenges and rolling with the punches and going, okay, the contractor did it this way, but we needed him to do it that way. And that's just par for the course. So they're in it for the long haul to make sure that the projects go well and that you use them again. So check them out, mwconnect.us. But thank you for joining us today. And Steve, thank you for joining us. This was a great conversation. We're definitely going to have a part 2 for this.